question 8b has to do, again, with conservation of energy. So we can write out our energy balance. Potential energy initial plus kinetic energy initial plus work minus loss is equal to potential energy final plus kinetic energy final. And in this case, we're going to cross off some terms because initially the string is stretched by 4 meters, so we're going to have potential energy. We don't have kinetic energy because it's not moving. This one was kind of tricky. Hunter did work to get the spring into the position that it was at before it was released, but once it was in that position, there was no work being done on the spring, so you can cross that term off, and again, there's no loss from the spring. Then in the final state, we're 1 meter from equilibrium, so we still have some spring potential energy, and we have some kinetic energy because now the spring is in motion. So that gives us that potential energy initial of the spring is equal to the potential energy final of the spring plus potential energy final of the spring plus the kinetic energy final. And that gives us 1/2 kx squared. And this is x initial. This is 1/2 kx final squared plus 1/2 mv squared. And plugging in numbers, that gives us 1/2 times, what's k? 8 times x, which is 4 initially, and then 1/2 k again times the distance is 1 for the next point, and that's equal to 1/2 mass, 1 times velocity final squared, and you end up getting a final velocity of 10.95 meters per second if you solve for v.